All right, last class I went through the first method for solving this exact same complex fraction. The first method, remember, involved rewriting the numerator as a single fraction, rewriting the denominator as a single fraction. That's from the 4.3 section, and then inverting and multiplying, that's from 4.2 section, and then simplifying, that's from 4.1. This second method is a little more efficient. It can be done quicker. However, it's only more efficient for specific types of problems, and I'll try to explain what types those are. But when you're using this second method, what you're going to do is you're going to multiply the numerator and denominator of the entire complex fraction by the LCD of all fractions over itself. Okay, so what that means is we're going to, if we think of every term as a fraction, when we look just at the numerator and then just at the denominator, we want to multiply that by the LCD of every fraction involved in this problem. So when we look individually, term by term, we have a denominator factor of 1, x, and then x. We already have the x, so we don't need a new one. So our LCD is just x here. So we're going to write that over itself. Again, this maintains the identity property of multiplication. We're not changing the value of the fraction, only its form. Okay. Once we get to this step, what we're going to do is we're going to work just in the numerator, and then after that just in the denominator to simplify our fraction. Okay, so we distribute our x. X times x is x squared. X times 1 is 1x. X times negative 6 over x. Here the x's cancel, leaving just a negative 6. Okay, now we can move to our denominator. When we look at our denominator, we distribute through. In this case, it's just a monomial factor, so we're not distributing, we're just multiplying. 1 over x times x is just the value 1. So after we get rid of our complex fraction, we're going to end up with one single fraction, which we then simplify. So when we simplify the remaining fraction here, all that needs to be done is you could factor this if you wanted to, and you have your solution. Okay, so this second method, this LCD method of solving complex fractions, can oftentimes be a little bit quicker. The one thing, so the advantage is it can be quicker. It only works when the number of distinct LCD factors is 1 or 2. It can work with 3 as well, but there's other things that have to come into play. So really, if you have 1 or 2 distinct LCD factors, you can go ahead and use this, and it should be more efficient. Anytime you have more than that, so 3 or 4 or more different LCD factors, the first method is a little bit easier to manage. Otherwise, you might be dealing with higher degree polynomials like cubes and powers of 4, things that you don't really want to work with. Now, notice I put this asterisk here because the disadvantage to this method is you can't see the domain-restricted factors being canceled. So you have to pay careful attention in how you identify domain restrictions. So when we come back here, you have to check through the entire process of the problem. It's usually easiest just to look at the beginning. In the beginning form, are there any values that you need to restrict? What do you know x can't be? Is that shown in the simplified form? No, so you have to identify that individually.